Hi everyone, Roselle here. I'm a bit late with my submission because I was trying to figure out how to record video, but thanks to Stuart, some pretty cool software to stream what I'm doing in our studio. So let's get to the midterm project. My approach to the model building was to look at everything at a high level, um, from an EDA perspective, just to see what was missing, the outliers, whether I was going to cap or trim based on looking at the quantiles, which I did. And I think a lot of people have spoken to the EDA piece, and I'm just kind of going to move through my approach for the model building. So the challenges that I'm having with the model building right now are that there are so many time series within this data set, because when we go to the shop item level, that essentially is a time series in itself. So multiply that by the number of items per shop that are sold, and then there's at least 60, I think it's 60 shops in the entire data set. Not necessarily what is in the test data set that we have to actually forecast for, but just, actually building on a training data set with all this, just such a high volume of data is, for me, processing time is taking a lot of my time doing anything really. So I've been looking for ways to get around that by not using a lot of for loops and trying to use apply, but it's taking a bit of time to get myself accustomed to that. So back to my screen. I've been talking too much. In building the models, I adapted the week 4 sync session code that Professor Holton had showed us, looping through the shop and the products. So to run that for even a single shop with thousands of products takes over 30 minutes. So I've just kind of distilled it down to look at a single shop and a single item. So the first thing I had done as part of, my kind of going a level deeper with EDA was to look at the single shop number 5, and this was item 30. And as you can see, it has a lot of sales in the early months. So this is January 2013, and there are 0 sales and gaps as we lead up to my test set. Actually only goes up to 23, block num 23, which is about, I think, the end of 2014. Right, the end of 2014. So that's what I'm going to try to build my model on. At first, my first pass is just to build an auto ETS and an auto ARIMA. And when I actually run it, I get, so this is just a count of the total monthly revenue for the single shop and a single item, just to get a feel for how my code should run, because I don't want to keep testing my code at such a high level, wasting time. I want to verify that my code works at the micro level before scaling it out to the macro. And so I run through this code, and at the bottom, I've already actually run it, it took a little time, was to just isolate shop 5 and item ID 3. And I've already kind of put the forecast object into a list so that I can cycle when I start to scale out, I know I'm going to go back into this list and review all the forecasts that were built. I'm not quite sure how I'm going to compare all the models to determine which one is the better kind of fit, because every model will be different for every item and product. So we'll see. This is the stage that I'm at, and I'm still kind of experimenting. I've been reading through some journal articles around using XGBoost, and I think you can take it to a different level. You don't have to go item level, shop item level to run that algorithm. It's kind of like a decision tree, and we'll go through the whole thing with that. I assume, I just only read it once. So if I actually, oops, sorry about that. If I run this back to my model, I get an ARIMA with 1, 0, 0, 0 mean. This is the data in my training set and the forecast for the next month. So that would be block 34 is pretty much 0. and that's just based on looking at the historical data. With ETS, it's additive, no seasonality, no trend, and very similar. So this is what I would expect to see as I try to scale this out across other products, which is essentially rerunning this for loop over and over again. I'm still not 100% sure how I'm going to select the best model, whether I aggregate the RMSE up to a higher level and then just compare that as a singular number, or I was, watching the other videos and seeing that another approach might be to kind of break it out by high, medium, and low, and then build models at that level. So I think I'll give that a try. I wanted to actually run through the entire data set, possibly have to leave it overnight, and then generate a submission file for Kaggle, and then see what my benchmark baseline score is. All right, thanks. Good luck, everyone.